Hi everyone. So today we are going to do some more mathematics on mensuration and two-dimensional. I'm not going to three-dimensional directly. You should clear your concepts on 2D first before proceeding to 3D. 2D is two-dimensional, plane, all the shapes are on a plane, so on a plane surface. So what are the shapes? So first of all, any four-sided figure is known as 2D. I covered triangles in a prior video. You can refer to that. Today we will not go cover triangles because it's already covered. I'll cover quadrilaterals, four-sideds. Four-sided closed figure are called what? Quadrilaterals. Oh my goodness. Quadrilaterals. So what is a quadrilateral? Any sided four closed figure. Now you can ask me, four sides, 1 2 3 4, is this a quadrilateral? Is it closed figure? No, right? It's not closed, it's open. This is not a quadrilateral. Is this a quadrilateral? No, it is. If you remove this line, then it's a quadrilateral. So now you know this is a quadrilateral. This is a quadrilateral. So these are quadrilaterals. So normally there are some special types of quadrilateral. One of them is parallelogram. So next we move on to parallelogram, special type of quadrilaterals. Parallelogram. What is a parallelogram? Whose opposite sides are parallel and equal. So I might not draw a perfect figure. This is a parallelogram. It doesn't look like a parallelogram. This looks like a parallelogram. This is a parallelogram. So what are parallelograms? Parallelograms are quadrilaterals. That is first thing. First definition. We started with quadrilaterals. That means four-sided closed figure. Quadrilaterals whose opposite sides are parallel and equal. Like this parallel. Is this a parallelogram? No, because the opposite sides are, this one is parallel, seems to be parallel, but these two are not parallel and they are not even equal. This is not equal to this. No. So this is not a parallelogram, it's a quadrilateral. So all parallelograms are quadrilaterals. But all quadrilaterals are not parallelograms. Clear? Yes. Now what are the various types of parallelograms we have? First of all, rectangle. Second is square. Third is rhombus. Anything else you can think of? Parallelogram. I mean, parallelogram. This is already a parallelogram. So this is not a special figure. Rectangle, square, rhombus. What are rectangles? You know rectangles, everybody knows. Rectangles are when four-sided quadrilaterals where the opposite sides are equal. This is known as length, this is known as breadth, this is L. Let's quickly draw area and perimeter. Area, how do you make a rectangle? You know, right? If I say this is a rectangle. Now how do you name? You remember my first class? If you make many points, you get a line. If you make many such lines, one over another, example is books, each page in the book is a line, you get this figure, you get a book, right? Sorry, I am not drawing it to the perfection. You keep on drawing. This is a rectangle. Okay, so pages, a single page, if you see the tip, book, take a book. I can explain it with a book. Let me see if I have a book. I can show that. See, I'll show you this with this copy notebook. See, in a book, if you take a single page, this is a line, but one line, second line goes, third, fourth, fifth, sixth, seventh, eighth, whatever, and ultimately this shape which you see is a rectangle. I hope I'm clear. This is better look. See, lines over lines over lines. So that is why you have, say, 100 lines. Let's say we have 100 lines and 100 lines and each of length L 100 lines. So 100 lines into 100 lines, length of each line is L. So what will be the area? Length into 100, that is breadth. That is where breadth comes into picture. This is breadth. So that is why area is length into breadth. Perimeter is very easy. You do want to fencing around your whatever lawn, L plus B plus L plus B, that is 2L plus 2B, that is 2 twice L plus B, and it's a length. This is a length, always remember. This is 1D, length is always 1D, area is always 2D, volume is 3D, which we are not covering at this point of time. So done with rectangles. Move on to square. Square has all sides equal. Very good. It is a special type of rectangle. Square is a special type of rectangle where adjacent sides are equal. Here L and B were not equal, but if they are equal, we can say it's a special type of rectangle which is known as square. So you go take the same formula. L is S, this is L, length, into S, that is S square. Perimeter, S plus S plus S plus S, 4S, 4 into side. Rhombus. Now rhombus is a little tricky. Rhombus is a little tricky, but still, how do you calculate rhombus? See, I'll tell you. You divide this like this. You divide into two triangles. Now, the diagonals of a rhombus meet at 90 degree. You must have heard that, read that. Diagonals of a rhombus intersect at 90 degree. So, you know triangle, right? It has two triangles, right? You see the first triangle and you see the second triangle. So, half base into height. This is first diagonal, d1 plus, into height. Say this is h1 and this is h2, h1 plus half d2 into, no, again half d1 into h2, half d1 into h2. I am deriving this. So that is, take half d1 common into h1 plus h2. So half d1, h1 plus h2. What is h1 plus h2? This one was h1, this one was h2. So that is the second diagonal. That is diagonal 2. Half first diagonal into the second diagonal. It's a little complicated. If you find it complicated, let me know. I'll explain it again. But rhombus, let me explain again. I'm not satisfied with explaining it. I take a bigger rhombus. See, you divide first into two triangles. This is triangle 1, this is triangle 2. This is the base for both the triangles. This is the height for the first triangle and this is the height for the second triangle. So this is h2 and this is h1. Half base, this is the first diagonal, right? This shape, this diagonal is d1 and this diagonal is d2. That they are meeting at this point. Say, this is the cutoff point. Now, half h1, this I am telling h1, this I am telling h2. So half d1 into h1, half. Try to understand this. This is half. This is the area of, and perimeter is 4 into s because all sides of a rhombus are equal. What is a rhombus? Rhombus is not a special type of square. Rhombus is where the two adjacent sides do not make 90 degree and all sides are equal. That's the definition of rhombus. And remember one thing, that diagonals of a rhombus are perpendicular to each other. Diagonals of a rhombus are perpendicular to each other. I hope I made myself clear. Rectangle, square, rhombus. There is another figure which I should tell you. I hope you are clear on this, right? Okay. There is another figure. That's not a special type, but it's something which you have to cover in your 2D. Two figures, 2D. On plane, how many you can draw, right? You can draw anything. Trapezium, quadrilaterals we covered, right? That is why we need to cover another figure which is known as trapezium. What a trapezium? One pair of opposite sides are parallel and not equal. So see, this side is parallel to this side, but they are not equal. This is shorter, this is longer. Forget about the other side. They can be equal, they cannot be equal. So how do you calculate area? Perimeter is simple. You add all the sides. I am not going to perimeters. Area is, how do you know? So that is where you do this. Say this is L1, this is L2. They are not equal. the lengths, the opposite sides which are parallel, let them be L1 and L2, and let the height be h. Let the height be h. Okay. Now this is a rectangle. So rectangles, what is the L1 and what is this? Is L1, this whole is L1. So how much is this? Half this area. This area is, how much is this? Half base into height, half base into height. Say this is B1 and this is B2. Okay, half B1 into h plus L1 into h. No, this is L2 into h. Sorry, L1 is this whole. L1 is this whole, please. And another thing you have to remember, B1 plus B2 L2 plus B2 is equal to L1. This is B1, base of this triangle. This is B2, base of the other triangle. This is L2. It is equal to L1. This is L1. So half B1 into h plus that this triangle is covered. Now let's come to this rectangle. Half L2 into height. Half L2 into height. The second triangle, half B2 into h. Now you take half common, h common to B1 plus L2 plus B2, and B1 plus L2 plus B2 is nothing but L1. So half h half, hold on, area is half V1 into h, half L2 into h, B2, B1 plus B2 plus L2 is B1 plus B2 plus L2 is L1. So half h into L1. I made some mistake. Half base into height. This one is not half, sorry. This is length into breadth. This is length into breadth, right? Length into breadth. That is why I am thinking breadth. So if you take 2 common here, half, then this becomes 2L2. Correct? Now you break this B1 L2 into L2 2 times, one here and one here, and B2. Now B1 plus L2 plus B2, B1 plus L2 plus B2 is L1. So half H L1 plus L2. So the formula for a trapezium, this is a trapezium. I should have told that in the very beginning. What? This is a trapezium. This is a little trickier. Derivation of the formula is trickier. Solving the problem is not trickier. So half sum of the two parallel sides L1 and L2 into height. This height is always the same. This height, all the perpendicular lines, not from here, from here to here. Okay. So this is how you derive quadrilaterals. Apart from quadrilateral, I'll cover another shape which is covered, circles. Let me cover that too, because then that will cover 2D, everything about 2D. Circles. Derivation I won't go. I'll simply mention circle. Some definitions. This is a circle. This is the center. center from any line is radius. You know that all lines are equal. This is r, 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 radius r. And you know diameter, right? R plus r. Diameter is 2r. 2 into radius. This is 1. And rest is very simple. Area equal to pi r square, where pi is equal to 22 by 7, or you can also take 3.142, or and that is the area. And what is the perimeter, which is known as circumference? Special word that is used. Circumference means perimeter, the outer length. If you want to cover it with a thread and you want to know how much length that thread is, that is circumference, the outer length, that is 2 pi r. And sometimes if you know 2r, that is t, diameter, pi into diameter, whatever. I hope today's class was not boring. Let me know. I'll cover 3D in one of my next lectures. Thank you so much for watching. Please do like, share and subscribe if you like the video. Thanks so much for watching. Have a nice day. Bye.